Hello, everyone. Thanks for attending this presentation. My name is Arash Bayat, and I'm from Health and Biosecurity at CSIRO. Today, I'm going to talk about understanding polygenic disease with BitEpi and Epi Explorer. A complex phenotype may be driven by many genes. Some of them individually and some others interactively contribute to the phenotype. Traditional GWAS study look for individual genes, or more specifically, individual genomic locations or genomic variants, to see if they are relevant to the phenotype statistically. In case of epistatic, we look at combinations of genes together, like two or more genes combined together, and see if the combination shows any statistical relevance to the phenotype. Of course, this is far more complex problem because the number of combinations is far beyond the number of individual genes. And as we go for higher number of genes in the single combination, the computational complexity exponentially grow because the number of combinations exponentially grow. So finding out these statistical interaction is important because they are clue to find out complex genomic pathway, complex biological pathway, which are controlled by multiple genes in the genome. So how we can find these complex interactions? Definitely, we can't test all combinations in human genome with millions of genomic locations, so there should be a way to reduce the search space. VariantSpark is a machine learning software that can help you with this problem. It basically can give you a subset of genomic locations which are responsible for most of the interaction in your dataset. Once you reduce the search space, BitEpi is a fast and exhaustive search that can test all possible combinations of up to 4 interactive genes. Being faster is critical because with the same computational budget, you can process more genomic locations and ultimately identify more interaction in your data. There are other software that perform exhaustive epistasis search, like BOOST and MPI3SNP perform search for two-way and three-way interactions, and they both use the same bitwise optimization that makes them order of magnitude faster than other existing software. BitEpi introduces a novel bitwise approach that is perfect for 3- and 4-way interaction, more efficient and faster. And also, it turns out the statistic that we use in BitEpi is more accurate than those used in BOOST and MPI3SNP, and we figured it out by testing them on synthetic data sets. So once you run BitEpi on your dataset, you will end up with a large number of statistics for pairwise, 3-way, 4-way interaction, as well as individual genomic locations. And that's because of the nature of the problem that we are trying to solve. We are looking at a complex phenotype where there are many signals involved in it. So we realized that there should be a software that lets you to explore all the statistics that we discover with BitEpi, and that's why we create Epi Explorer. So the Epi Explorer takes the output of BitEpi and any genomic annotation you have, and then turn it into a dynamic cytoscope graph where you can where you have basically endless opportunity to plot the data exactly in a way that you can make discoveries out of it. I'm very keen to discuss about details of Epi Explorer in a follow-up discussion session. So if you already have a data set that you use it for GWAS analysis, why don't you try our pipeline BitEpi and Epi Explorer on your data set? There might be some interaction in your data waiting for you to discover. So it's free of charge. You can try it, of course. Thanks again for your attention. I hope you enjoyed this presentation.